Alright, so today it is 3/4/19. So today what we're going to be doing is graphing parabolas. So parabolas are any x squared. Any y equal x squared equation, okay? Any y equals x squared equation is going to be a parabola. And parabolas have a certain shape to them. They're kind of curvy, and we're going to see exactly what they look like here in a second. Okay, so graph y equals x squared. Okay, this is going to be a parabola. This will be a parabola because of the x squared. So if we do a t-table, okay, here's my x's, and there is my y's, okay. And you've already done the t-table. You have. Because we're going to take each of these numbers and we're going to plug them in. We're going to plug in 0. So again, what is 0 squared? 0. So if you plug in 0, 0 squared is 0. What is 1 squared? Plug in 1, 1 squared is 1. What is 2 squared? Plug in 2, 2 squared is 4. Plug in 3, 3 squared is 9. Good. And we know negative 1 squared is positive 1, negative 2 squared is positive 4, and negative 3 squared is, okay, good. So these are points. These are coordinates of points from a t-table. So my points really are 0, 0, I've got a 1, 1, I've got a 2, 4, I've got a 3, 9, I also have a negative 1, 1, I've got a negative 2, 4, and I've got a negative 3, 9. Okay. So I want to graph those points. These are all coordinates of a point. I don't see anything that has negative y's, right? There's no negative y's, so I'm just going to put my graph like down here like this, way down here like this, because I know that there are no negative y values. They're all positive. That makes sense because when you square any number, it becomes positive. You will not have any negative numbers, okay? So let's do a little t-table on this, right? So 0, 0 is a point there. 1, 1 is over 1, up 1. 2, 4 is over 2, up 1, 2, 3, 4. 3, 9 is over 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? And then negative 1 squared is positive 1. Go over 2. Negative 2 squared is 1, 2, 3, 4. And 3, negative 3 is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, we're going to connect the dots because there's also numbers in between, decimals, but we wouldn't want to do those. Just connect the dots, right? We know that 1/2 is in there, 1/2, 3/4, all the numbers in between. That's why we connect the dots. Okay, there's a parabola. That is the parent function, okay? That's our parent function, okay? Now, we're going to take this parabola and we're going to change it. We're going to make it taller, shorter, we're going to move it. But we take this shape and move it. Now, real quickly, this is kind of curvy, it's not pointy. It's not pointy. Remember when we did the absolute value graphs and they were V's and they're pointy. This is not, it curves right here. Okay, does that make sense? Okay, don't make it pointy, make it curvy. All right, so now let's take a look at example 2. So to graph y equals 2 of x squared, what I need is my parabola twice as tall. It's going to be twice as tall. So it really is a vertical stretch. All right, let me go ahead and start here. And I'm going to have to change some things a little bit because I got to go real high. So I think I'll go by 2's on the y-axis. I think I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and maybe 30 way up here, okay? And the reason I'm going so tall is because this graph is going to be twice as tall. I'm going to stretch it. Does that make sense? So I'm going to take my parent function. I'm going to make it twice as tall. Ready? Here's what I'm going to do. I'm going to take its heights and double the heights. Okay, so let me put down the original.
Wouldn't you square it instead of doubling it?
I'm gonna square it then double it. I'm gonna square it then double it. Okay, Let me put down the original. 1, 1, 2, 4, 3, 9. Here's my original, okay? It looks something like this. You guys don't need to put this in here, but here's my original graph. Here's my parent function right there, okay? Now, let's take this parent function and just make it twice as tall. It's as easy as this, okay? We went over 1, up 1, didn't we? So instead of going up 1, let's go twice as tall, up 2. So we're going to go over 1, up 2. We went over 2 and went up 1, 2, 3, 4. We want to go twice as tall. Let's go up to 8. Am I making sense? Twice as tall. So the original graph has a height of 4. The original graph has a height of 4. Let's make that twice as tall. So instead of going to 4, let's go to 1, 2, 3, 4, 5, 6, 7, 8. Yeah, Damien?
But you numbered it, you just went to like...
Oh, I did do this wrong.
14.
Thank you, that is my mistake. Darn it, I need whiteout on me. Let's go get some whiteout. Good man. That's totally great. Thanks for finding my mistake, Damien.
Follow my Snapchat, Damien5902.
Okay, so now,
Yeah, it's just so fun.
let me get rid of that point. So now, next one. So you ready? Let's take a look at this graph right here. We went 3, and 3 squared was 9, right? But instead of going 3 squared being 9, let's go twice as tall. Instead of 9, we go to 18, right? So we go 3, 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 18 there, okay? Now, it's going to be symmetrical. Does that make sense? Take a look at the original graph. It is symmetrical. What's here folds over is also here, right? So to get the other points, let's just go and do folding over. One's here, and then we'd be at positive 8 here, and we'd be at positive 18 here, and here's my graph. Now if I compare it to the parent function, here's my parent function, okay? This is my y equals x squared. That's my parent function. And if I compare it to my y equals 2x squared, they have the same shape, don't they? They're both parabolas. They have the exact same shape. They're both that loopy thing, right? Okay. But the only difference is the one in red is twice as tall. It's a vertical stretch. It's twice as tall. Here's what we did. Okay, listen. We went 1, 1. Because what's 1 squared? 2, 4. Because what's 2 squared? We went 3, 9. Because what's 3 squared? Now let's go twice as tall. Instead of 1, 1, I'm going to go 1, twice as tall. 1, 2. Let's go 2, 4, but let's go twice as tall. 2, 8. Let's go 3, 9. Let's go twice as tall. See how it works? It's actually pretty easy, isn't it? Hi, Artrum. Here are the notes for you, okay? All right, turn the page. Okay, now, so with a negative, the only difference is your y values become negative. So if your y values become negative, you're not going up, you're going to have to go down. Does that make sense? But in this case, half as tall, okay? So I'm going to make my xy axis way up here because I'm going down. So I'm going to go ahead and put my x-axis here, my y-axis here, because I'm going down. So here were my points. My original points were 0, 0, 1, 1, 2, 4, 3, 9, right? And then I also had a negative 1, 1, and I had a negative 2, 4, and I had a negative 3, 9, right? You guys with me? And that would be my original, and that's my parabola that looks like this. Okay, here's my parent functions up here, okay?
Wouldn't it just be wider?
Okay, yes, you're way ahead of me, okay? Now, here's what I'm going to do. I'm going to take all of these numbers, these are my y's, take all my y values, and I'm going to make them half as tall and negative. Okay, I'm going to take all of my y values, I'm going to take them and multiply, so I'm going to multiply all of these by negative 1/2. Does that make sense? So my new points are going to look like this. I'm going to have a 0. Well, 0 times anything is 0. You guys agree with that? But here's where it gets different. I'm going to have a 1. But what's 1 times negative 1/2? Negative 1/2. Say it again. What's 1 times negative 1/2? Negative 1/2. Okay, I'm going to have a 2, and then what's 4 times a negative 1/2? Negative 2. Everybody see that? Negative 2? Let's take a 9, and half a 9 is 4.5, but a negative 4.5? Yeah, I'll wait for you. So I'm taking half a 9. Half a 9 is 4.5. Were you with me? 9 halves, 4.5. But then I make it negative, right? I'm going to take negative 1, but I'm really going to take this 1 and take negative 1/2 of it. I'm going to take this 4, multiply the 4 by, take half of it.
Wait, why wouldn't you do a negative?
Because of the negative 1/2 right here.
You don't need to?
Well, you could fold it over.
Yeah.
Yeah. Let me keep going, Derek. Okay. So I'm going to get a negative 2,
Never mind.
negative 2, and then a negative 3 and a negative 4.5. Okay. So that is one way to do it, is to take your scale. It's called my scale. One way to do it is take my scale and multiply the y values by your scale. Gives you your new points. Say it again. One way to do this is take all of your y values of your parabola by your scale, and you get new points. Okay. Another way to do it is this. Here's what I do. Okay. Okay. I go 1, 1, but let's go half of that. What's half of 1? 1/2 will go down. Okay. 2, 4. What's half of 4?
2.
But let's go down. 3, 9. Let's take half of 9. Half of 9. 4.5. But let's go down. You see why I'm going down? Because of the negative. Okay. So here's what my graph's going to look like. I'm going to have a 0, 0. I'm going to have a 1 and a negative 1/2. I have a 2 and a negative 2. A 3 and a 1, 2, 3, 4.5. And I know, just like Derek said, Mr. Davies, why do you need to do these? We know it's symmetrical. That's what you were saying, wasn't it? So Derek's right. I don't really need these because I know I have a mirror image of it here. I got another mirror image of it here and another one right there. So let's see what we got. It's half as tall. So it's a vertical shrink. It's a vertical. And it's upside down, so it's a reflection. Reflection over the x-axis, okay? So it's a vertical shrink, and it's a reflection of the x-axis, and that's what my parabola looks like, okay? And we're going to practice these a bunch. All right, let's look at example 4. So a parabola has points of negative 2, 2 and 4, 2. What is a possible vertex? Oh, gosh, if I can get a piece of graph paper, that would make it really easy. So let me see. Do I have a piece of graph paper somewhere? All right, if I can see it, I can do it. Okay, I'm going to grab a piece of graph paper. Let's see what I got. Let's see what I got. Okay, so I've got, let's see, if I put a graph, this is so easy if I graph it. It really is. All right, let's see what I got. Okay. So I'm going to have a point at negative 2, 2. That's there. And at 4, 2. Right there, okay? There are lots and lots of places the vertex can be, but they all have to lie right along this line. Except for it can't be that point right there. Can't be this point right here. How come? Why couldn't it be this? Why can't it be that point right there?
Because they don't go.
It's not. Yeah, it's not a flat line, right? Yeah, it's got to be. It's got to be curvy. It's got to have to. So, hey, how about this point? Could that be a vertex?
Yes.
Sure. How about this point?
Yes.
Sure. How about this point?
Yes.
So, I don't know. What do you think? Give me one. Which one do you like?
X equals 1.
Okay, so one, what? Please don't say 2. 1, 5 is awesome.
Why not 1, 2?
1, 2.
Don't say 1, 2.
1, 2.
Can't be 1, 2, because Cameron said then you'd have a flat graph, wouldn't you?
1, -2.
I would go along with 1, -2. I would go along with 1, -2. Yeah, and there's a whole bunch of answers that are right, but not that one there. Thumbs up on that? That's pretty easy. You guys agree?
Yeah.
All right, now, last but not least, example 5. So, we've got a parabola, and it's going to pass through the point 2, -5, okay? This is like our egg drop, when we did our egg drop, okay? So if I've got a parabola and it passes the point 2, -5, right? Then the parabola has to look something like this. Has to. Has to.
Why can't it be like this?
Oh, remember we talked about functions?
Yeah, but it does it have to be a function?
Right. You would have to have a y squared here, Derek. Really good
Oh.
question. It would be a x equals a y squared, okay? Let's do those in pre-calculus, okay? Okay, we don't want to do those yet. Okay, now, so what I want to do is find this value here. We did this with our egg drop, okay? So let's change this to y equals ax squared, okay? And I want to find the value of a. All right, I can do that. Every point has an x and a y value, right? We're going to put our 2 in for the x and our -5 in for the y. I'm going to put our 2 in for the x, so I'll put our 2 right here for my x, and we'll put my -5 in for the y. Now it's easy, because all I did is I put the xy, put the 2 in for the x value, and I put the -5 in for the y value, and I'm just going to solve. Okay, so to solve, -5 equals a times 4, because 2 squared is 4. Divide by 4, divide by 4, a is equal to -5 fourths. Oops, -5 fourths. I don't know why I wrote y. -5 fourths. So my answer, this equation should be y equals a -5 fourths x squared. Okay. Let's check out our journal. Let's see what our journal has to say, okay? Let's go to page 76. Let's check out our journal.